Today we'll take a look at Typst, and chances are that once you see it, you're going to stop using LaTeX for a lot of different use cases. Typst is essentially a typesetting system. You can think of it to be a little bit like a combination of LaTeX, Markdown, and maybe even Python. You essentially use it to program PDF documents. I think most of you guys will find it interesting. If you like this video, let me know by hitting a like button and subscribing, but now let us get right into it. Alright, so let us take a casual look at Typst. This is the GitHub repository. Typst is open source, so you can see all of the source code. It's written in Rust, which gives you street cred as well if you want to use it or develop it even. And the idea here behind Typst is the following. You start with some code that looks like this. This looks like a little bit like a combination of Markdown and Python, maybe Markdown and JavaScript, and that turns into a PDF document that looks like this. And as you can see, this is already much more readable than something like LaTeX with all the backslashes, with all these long command names, and with all these curly brackets and everything. This is pretty straightforward for someone who knows how to code and understands basic pseudocode syntax, essentially. This is very convenient for writing documents like this. And this is, of course, a bit of an overkill example because we have a lot of math in here and we have tables and everything. But essentially, there's also a full documentation where you can look up everything that you can do with Typst, the mathematics, the text, the importing of data, the visualization of stuff. There's also plugins and packages. My goal with this video today is to just give you an introduction into Typst. I want to show you a couple of different things you can do with them, some interesting things that I myself find useful, and then you can go and explore it on your own using the documentation. Now, the only thing you need to do is you need to get Typst onto your system. Then it's quite straightforward how to use it. On the GitHub page, you will find the installation instructions. This is platform independent. On Mac, you can use Brew. On Windows, you can use Winget, whatever that is. And on Linux, it depends on your operating system. Or if you want to keep it simple, you can also use Snap. I don't like Snaps. On Arch Linux, if you're cracked like me, you can use the extra package. So just pacman-s Typst, and then you have it on your system. Whatever your operating system is, just get Typst onto your system. Now, once you have Typst installed on your system, things become very easy and straightforward. You can run Typst in the command line to see if you have it. If you see this message here, you have it installed on your system. And all we need to do now in order to create a PDF document is we need to create a file called something.typ. In my case, let's call it main.typ. And in here now I can put in the raw text, hello world, for example. Now, to turn this into a PDF document, all I have to do is I have to say typst compile main.typ. This will result in this main.pdf file. I can use Ocular to open it, and there you go. We have a Typst file compiled to a PDF document. Very easy, as simple as it gets. Now, of course, we can do much more than that. I can go into the Typst file here, and I can add, for example, a heading. How do I do that? It's a little bit like Markdown, but you don't use the hashtag, you use the equal sign. So here, for example, that would be a heading of size 1. Then an additional equal sign would be a heading of size 2. And then for size 3, I would use 3 equal signs. Then I can run Typst compile again. Maybe let me combine this with Ocular main PDF. So I have one command to compile and open. And there you go, we have headings of different sizes. Then, of course, we can do other basic stuff. For example, I can do lists. I can say my list, and then I can either use the minus sign, so the hyphen, to say this is a bullet list. So I can say hello world, what's up? Then I can also go, for example, under what's, and I can use the plus sign to do a numbered list. So that would be 1, 2, 3. The indentation is important to make it a sublist. The plus makes it a numbered list. If you use a hyphen, it's a bullet list. So I can now run this again. There you go. Hello world what's, then 1, 2, 3 as a numbered list here. It's quite simple and straightforward here as well. What else can we do? We can also include an image. For this, I had to briefly go and find one. So this is now the Neural9 logo.jpg. How do I include this into a PDF document? Quite simple. I just go in there. I use a hashtag to say this is now a special command, image, and the image is just going to be here in double quotations, nn_logo.jpg. That is already enough. I can compile this and we will see the image here in the PDF document. But I can, of course, also specify special sizes. So I can go back here and I can say, for example, what was the command width? And then I can provide a percentage. For example, fill up 70%. If I do that, you will see that this is going to be a bit larger. You can also see it gets blurry because the image is not that large. But that is also something that we can do here. If I don't want to just have an image, if I want to have a figure, what I can also do is I can wrap the image in a figure, or I can wrap a figure around the image, and then I can also link to that. So for example, how would I do that? I would say hashtag figure, and then I would make the image be part of that figure. So I would remove the hashtag here, I would indent this, and then I would also add a caption. The caption is just a key value pair here, so caption colon, then I would use curly bracket, not curly brackets, sorry, square brackets here, and I would do something like, this is the logo of the best YouTube channel, for example. Just an example. And then we can use here angle brackets to say this is logo. And by doing that, I can now say look at and then at logo. So what happens here is I have a figure. This figure contains an image. I can remove this width here if I want to. I also have a caption. This is going to be below the figure. Then I have a link here, an anchor you could say. And here now I point to this link. So let's see how this works in the document. Now you can see a look at figure 1. Figure 1 is actually linking here to figure, and I also have the caption. But in my opinion, the most interesting part of all of this is doing math. So how can we do math here? Very simple and also very intuitive, I would say. It's a little bit like a combination of LaTeX and Python here, because you have to use dollar signs similar to LaTeX and Markdown, but you can basically write code like it was Python code. For example, I can say here sqrt of theta is equal to x to the power of 2 minus, I don't know, y over z or something like this. I just made this up now, whatever that is. And if I compile this, you can see that everything is rendered as it should be. So I have this fraction here, I have the x squared, I have the square root, and I have this special Greek character. Now, to not have to type all of this out manually, I'm also going to show you a couple of, or two more examples actually here for the RMSE and also for a gradient descent step. Quite simple, nothing too fancy here. I'm going to show you first of all what it looks like, and then we're going to analyze this in the code. So what I have here is the RMSE as text. This is just raw text, then a square root. Then I have sum from I equals 1 to n, and then I have this basic loss calculation here divided by n. And here I just have a simple step. So these are the weights, and the weights are basically the weights that we had before, but minus some learning rate times the partial derivative. Mainly did this here to show you how we can do partial. And this is extremely simple in Typest, because all I have to do is I have to write out what I want to have. So I say text to make sure that this is not a variable. This is not a special command, just text RMSE is equal to square root. Then we have sum. This underscore is similar to LaTeX. You want to say the lower part is I is equal to 1. And then to the power of n means the n is going to be at the top. Then I have hat to put a hat on top of y. So y hat I minus yi to the power of 2 divided by n. That's basically it. And here, also simple, theta underscore j turns it into a Greek character because I'm not using text. And then I just have alpha, another Greek character, dot partial automatically turns this into a delta j divided by partial theta j. So this is much, much more convenient. I'm not sure if I could improvise now the LaTeX code, but it would be something like backslash theta underscore j. And then for the partial, I'm not even sure how you would do partial in LaTeX, but it's just more verbose if you do that in LaTeX. It's way more convenient, in my opinion, if you do this in Typest. Now, another useful thing that we can do in Typest is formatting. We can either do that for a single piece of text, or we can do it for the entire document. For example, I can say here hashtag text, and then I can say that the font I want to use, so font here is going to be equal to Roboto, for example. I think the default one is Times New Roman or something that looks like that at least. And then I can provide here these square brackets, and I can say, for example, special text. That text now is going to have a different font. So I can either do that locally for a single text. So that here's the command. And if I scroll down, you can see this font is a different one than this font. But of course, I can also do that for the entire document. So I can go to main.typest, and then I can remove this. I can go to the very top, and I can say hashtag set, and then I can say text, and then I can use here parentheses, and I can say font is going to be Roboto. And this is now going to be applied to the entire document. So if I run this, you will see that everything now has this font. And this is not only for the font, I can also set up stuff like the page size. So I can say here, set page, and you can provide also a format. So I can say here, for example, paper, and I can say that this is going to be an A4 document. This is a standardized size. And now my PDF is in A4. I can also make it smaller and say it's going to be A6. So that is 1/4 of the size, I think. And now you can see how everything has to fit together in the smaller document. So there's a couple of styling settings. I'm not going to go through all of them. You can also set up margins and everything. But these are the things you can configure at the very top. They're only applied after you set them. So if I take this and I do this, actually this is now just math. If I do it down here, for example, wrong key. If I do it down here and I say special text, then we're going to see that the document changes at this point. So you can see I have special text down here. I have a smaller page, but up until this point, we just had the default settings. So the order matters. We cannot just do this anywhere and apply this to the whole document. This is like a command that changes the state. It's like imperative programming. It's not applicable to the entire document. But now we get to the even more impressive part, in my opinion, which is working with variables and functions. So what we can do is I can go ahead and say, I want to define a variable a. So let a equal 10. Then b is going to be equal to 20. And what I can do now is I can just print their sum. I can just have the sum as a value somewhere in the document. How do I do that? I say hashtag and then parentheses a plus b, for example. So I can go compile this, and if I scroll down now, you can see 30. So this is actually possible. We can use variables and we can do calculations with these variables. That is kind of useful, but the interesting part, in my opinion, is really working with functions. But before we do that, I want to show you also how we can use loops. We can also do conditions and loops and everything. Just a very simple loop here would be for letter in some string. ABC is one that is shown in the documentation, curly brackets, and then we use here in square brackets. What do we want to do with that? For example, I can say here, for example, hashtag letter is a letter, and then comma space. So what does this do? If I compile this, you will be able to see down here, for example, A is a letter. For example, B is a letter. For example, C is a letter. Because I'm using the control variable, the running variable, or whatever you want to call it here as part of the output. So I'm using actually this variable here with hashtag letter. I can also do that with a counter. So I can say, for example, let counter be equal to 0. And by initializing this, I can then go into a loop and say, while this counter, actually with a hashtag, while this counter is below 10, what I want you to do is I want to count up and I want to show also the number that we currently have. So I want to say here counter plus, or actually we have to say counter is equal to counter plus 1. And then I also want to show counter. How do I do that? As a tuple, basically I can just pass counter comma. And by doing that, when I go to the very bottom, 1, 2, 3, 4, actually it's not a tuple, it's the formatting. We have the parentheses, then we have the commas, and then we have the values 1, 2, 3 up until 10. This is our counter. But now let's move on to my favorite part, which is functions. How do we define functions? Very simple. We also use let, and then I can say square of n is going to be equal to n times n, for example. So now this is a function that takes in a number and returns the number squared. Quite simple. How can I use this? I can just say here square 10. And there you go. I can then use this in my document. So if I go compile this, scroll down, you can now see I get 100 because 10 times 10 is 100. And this can also be used in combination with other things. First of all, let me show you how we can also implement a more interesting function, a more complex function. Let's say factorial here of n is going to be equal to, and now we're going to specify also conditions. So we're going to make this recursive by saying if n is greater than 1, then we'll want to call factorial recursively with n minus 1. So how do I do that? I use curly brackets and I say return basically n times factorial n minus 1 without this. And I think, I'm not entirely sure, I think we need to do spaces here, otherwise the addition, the subtraction is not going to work. Otherwise, what I want to do is I just want to return 1. Now, of course, this does not take into account 0 and negative numbers. We're going to keep it simple here, but in order to return it, I need to also use curly brackets like this. And this factorial function now should work. I can say factorial of 10. This should give us some pretty large number. There you go. This also works. Now, in combination with that, we can also use external packages. For this, I'm going to copy paste now because I don't want to type this out myself. But this is just one example. Don't focus too much on this one. There's many different packages that you can use like this. This now imports here using hashtag import and some identifier, uses a plugin called Simple Plot. and we import simpleplot and add. What we do then is we define points, which are just range 1 to 21, mapping every n, so every number from 1 to 20 essentially, to n and square of n. The idea being we want to plot the square numbers, so we are going to have on the x-axis 1, 2, 3, 4, 5, 6, 7, 8, 9, and so on up until 20, and the y-axis will then have the square. So we're going to see the square function, essentially x squared, or n squared in this case, and then we're going to plot all of this using simpleplot. So just this is enough to create a PDF document with a plot of square numbers, of number squares, so to say. I actually think this is super cool and super convenient. So last thing I want to show you here, and then you can go and explore this more yourself if you want to, is how to load external files. So what I have here is I have a file called data.csv. Very simple. We have name, age, city, Alice, Bob, Carol, Dan, Paris, London, Berlin, Madrid, and then the age of the respective person. And now we're going to load this data and immediately render it into a table. And this is super easy. We can just say let people is equal to CSV. Then I just have to provide here with double quotations again, data.csv. And then based on this people data, I can now create a table. Easy, just like this table. Then I say I want to have 3 columns, columns 3, and then I'm going to say people.flatten. And I call this like a function. That's essentially the whole magic behind it. By running this now, at the bottom, I will have this information from data.csv in a table. So that's all I wanted to show you. This is kind of crazy. You can just code your PDF documents, and the more experienced you are with this, the faster and the more convenient of a tool this is going to be for you. So I would recommend checking this out. I'm not sure it will replace LaTeX for every use case that you have. I'm sure you can use LaTeX better for a lot of papers, although you can also include bibliographies and everything like this with Typst as well. But I think for simple document automation, like for example, for a CV, for invoices and stuff like that, this is a very convenient typesetting system. So that's it for this video today. I hope you enjoyed it and hope you learned something. If so, let me know by hitting a like button and leaving a comment in the comment section down below. Also, if you are interested in one-on-one tutoring or services, so in other words, if you need help with anything that is related to Python, machine learning, development, DevOps stuff, whatever I cover on this channel, if you need help with that, either on a coaching level, on a tutoring level, or actually me doing the work for you, you will find on my website 2 tabs, tutoring and services. There you can see what I have to offer, and you can contact me via email or LinkedIn. Besides that, don't forget to subscribe to this channel and hit the notification bell to not miss a single future video for free. Other than that, thank you very much for watching, see you in the next video, and bye.